Hi, I'm Evangeline, and here I'm with my friend today named...
I'm Tomas.
Tomas, okay, and we are going to be talking to you about density. Are you excited?
A little bit.
Okay, so I made this little contraption over here, and in it this is a 2-liter bottle filled with water. In it is an eyedropper with a little nut on the end, and I am going to show you some science magic. Okay, ready?
Yep.
So we're going to shine the light on this little guy, and we're going to see what happens. Oh my gosh. Okay, now you can turn it off. And look at this little guy, he's going back to the top. What? That was crazy. You know, sometimes I just wish that I was a Jedi and I could move things with my mind. Like if I just said to this, I could be like, hey, move down, and it would move down. What? Move up. Crazy. No, I'm just kidding. I'm a really bad actor, so I'm sure that none of you were fooled for 1 second. Anyway, so the reason why this little guy here went down to the bottom is because I was putting pressure on the sides of the bottle. Oh, what? Yes. So, and then when you release it, it goes back up. So why does this happen, you may ask?
Well, earlier you said we're going to be learning about density, so I'm guessing it's density.
Yeah, so maybe we should learn a little bit about density to tell us why that happens. So density is a big word, but really it means how much stuff is in how much space. So for example, you see these two squares. Imagine that they are the same size because they were supposed to be. This is a less dense square, so it has less matter in the same amount of space. So this would be almost like they don't like each other. The particles are more spread out. They don't really like being around each other. And this is more dense, so there's more packed together in the same amount of space. So this is like you getting together with your family and it's family reunion and everybody's kind of packed in. So yes, so they're the same size. They can be the same size but different densities and thus different weights. So we're going to test this out. I've got a nice little coffee pot here with some water in it, and I have a wooden block and a nickel, and they're different sizes. This one is bigger and this one is smaller, and we're going to hypothesize which one is going to float and which one is going to sink. What do you think? Sink or float? This wooden block. What's your hypothesis, Tomas?
Logs tend to float down the river.
Okay, he says float. What? It floats. You guys surprised? All right. Next, we have our nickel. Sink or float?
It's gonna sink.
All right. Yep, it sinks. You can maybe see it there. So, they were two different sizes. The block was larger, but it was less dense, so it looked more like this on the inside. And the metal is more compact and more dense, so it looks more like your family reunion. How does this relate to our contraption, you may ask? Well, this little guy is called a Cartesian diver, and when I squeeze, when you squeeze, it increases the pressure and forces water up into this little eyedropper, compressing the air at the top of it. This increases the weight, the mass, and the density of the diver, causing it to sink. But when you release it, the squeeze, it decreases the pressure on the top of the eyedropper, and let some water back out and some air back in. So yeah, that is our little talk about density. So thanks for watching, and thank you, Tomas, for helping and learning about density. Okay.